Here is such a nice looking geometric problem that I found on the challenge section of the Quanta Magazine. If you want to solve this problem, please pause the video because I'm going to solve this problem right now. So welcome to another video on prime logic. So basically there is a semicircle and we have two squares inscribed inside this semicircle. All we know is the side length of this square, the bigger square, is just 2 units. We don't know anything about the side length of this smaller square, and the question wants to know the ratio of the area of the bigger square to the smaller square. So basically we need to find and calculate the area of each of those squares and then divide the bigger one by the smaller one. Let's see how many times bigger the bigger one is compared to the smaller one. So we need to, at first, the very first thing and step and crucial step is to find out and to prove that the center of the circle, which should be somewhere around here, let's say. So this is the center of the semicircle or circle. It is also the midpoint of the side of this square. We don't know yet, but we need to, in order to proceed with the next step, we need to, yes, it seems so, it looks so, it is apparent, but we need to prove it geometrically or in other methods probably. So just imagine we don't have this square here. Just imagine we have just this chord. We have a chord right here. So from this point to this point, we have a chord. If we draw this perpendicular bisector of the chord, right, so it passes through the center. So if we draw this perpendicular bisector of this chord, it passes through the center of the square. So just imagine we don't have the square here. So this is just the perpendicular bisector of the square. So this divides the chord into 2 equal parts. So we know that the chord is just 2 units, right? So this must be 1 unit and this must be also 1 unit. And this perpendicular bisector is parallel to the side because this side is 90 degrees, right? This is a square. This is 90 degrees and this must be parallel to this side. Because these are parallel, this side also, this little segment must be also 1 unit. This is also 1 unit. In other words, this perpendicular bisector also bisects this bottom side of this bigger square. In other words, so the center of the semicircle, it is exactly the midpoint of this bigger square, the side, one of the side, this side of this bigger square. Now that we've proven and we've kind of illustrated that these are the same, now we can proceed with the next part. So for this approach, let's just draw this radius from this part. So let's draw the radius to one corner of this bigger square, and then we'll calculate it using this Pythagoras theorem. So we know that this is the right angle triangle, right? So this is the hypotenuse. So the hypotenuse, let's say, equals, so h squared equals 2 squared, which is this side of this right angle, plus 1 squared, or 5. So 2 plus 1, 4 plus 1 is just 5. So this hypotenuse or the radius equals square root of 5, right? So this is square root of 5 or just root 5. This is the hypotenuse here. Now let's draw another radius to the other side of, to this vertex of this smaller square. So we know that this is also square root of 5, right? This is the radius and we calculated using in the previous part. Let's name the side of the smaller square as x, right? So we don't know the length yet, but we know this part is 1, so this part is x, and so is this part. Now we can write down the Pythagoras theorem one more time in this triangle. So we have one side 1 plus x, another side x, and we have the hypotenuse, which is square root of 5. So let's write it down one more time. square root of 5 squared. So hypotenuse squared equals 1 plus x squared this side plus x squared, right? Now let's just distribute this fraction and this brackets now. So square root of 5 squared is just 5 equals 1 plus x squared plus x squared. So x squared plus 1 squared, or 1 plus 2x plus x squared. Let's just simplify that. So 5 equals x squared, 2x squared plus 2x plus 1. Let's bring 5 to the other side. So 0 equals 2x squared plus 2x. So plus 1 minus 5, it is minus 4, right? So now let's factor 1, 2 out just to simplify that further. So 2 times x squared plus x minus 2 equals 0. So this must equal 0, right? So x squared plus x minus 2 equals 0. So two numbers. We need two numbers. So here we have minus 2 and here we have 1. So the product of those numbers must be minus 2 and the sum of those numbers must be plus 1 or just 1. So just x, and we have one bracket and another bracket, x equals 0. So these two numbers are 2 and minus 1, right? So plus 2 and minus 1 equals 0. So in other words, each of those brackets must equal to 0. We can say either x equals minus 2, which is not possible because we are in, this is geometry, so we need positive values, or x equals 1, which is the correct value. So now we found the side length. So this was, the bigger one was 2, the side length of the smaller square is just 1 unit. Now that we have found the side length, let's just calculate the areas. The area of this bigger square equals, so 2 times 2, it is 4. Area of smaller square equals 1 times 1, it is 1. And the ratio, so the question wants the ratio of bigger square, let's say, to smaller square, which is 4 to 1 or just 4. So in other words, this bigger square is 4 times bigger than this one smaller square. So that's going to wrap it up for today, guys. I hope you enjoyed this problem. Make sure to share your thoughts and approach, please, because your approach is also very, very interesting and engaging and thought-provoking for me. So make sure to share your approach down in the comment sections below. And I have a bonus challenge for you. So that's not very difficult, it's easy kind of. What is the radius of the circle? Or what is the area of the circle? What is the area or the radius of the circle? I want you to find the radius of the circle and comment it down below. And make sure, and don't forget to like the video and subscribe to the channel if you haven't already. And see you on our next video on prime logic.